let's get started. Today's lecture, Digital Design and BIM, the third week, okay? So today's focus also on geometric modeling and rendering visualization using 3D Max, okay? So far, we have looked some BIM tools, including Revit, Family Editor, Dynamo, and so on. And recent 3 weeks, we quickly review 3D Max, using 3D Max for geometric modeling and some quick render and visualization for the specialized design visualization purpose issues using Autodesk material, 3D Max, Mental Ray, and some recalling what you have learned last semester, including some new features. And from today, and including rest of the weeks, we're going to use some BIM tools, family editors, parametric modelers, and some Revit, 3D Max, SketchUp, 3D warehouse, given geometry, and video-based presentation making, and some BIM-based design representation. Multiple applications we're going to use for your design development and visualization, and so on, okay? So the point here is you need to know various kinds of applications, pros and cons, and you need to take advantages of such applications, pros, okay, to avoid some cons. That's my point. And we have scheduled exam, and as always, lab exercise in each class, and the final project. One is your video upload on YouTube for your design studio work. Another option for the final is BIM-based design project development, okay? Or possibly you can do both, okay? You can do both, BIM-based design project and some video making, video presentation uploaded on YouTube. Anyway, here I list up what to do today. Today's focus, of course, geometric modeling, as well as Revit-based geometric modeling and interoperable work. Modeling by Revit and Family Editor, and rendering, visualizing in 3D Max. But based upon the experience this morning class, I think we don't have enough time for doing everything, I think. But hopefully we can walk through. But anyway, lab exercise 1 through 4, that's the main subject for today's lab exercise. Possibly lab exercise 5 and 6, the subject for next time, okay? Okay, let's see what we are using. Revit 2016, 3D Max Design 2015, AutoCAD, some other tools. But as you know, Autodesk 2017 version released. As you know, AutoCAD 2017, 3D Max 2017, Revit 2017, and there is Revit Architecture 2017. And take a look, the icons are updated, okay? Some 3D Max icons looking number 3, and R, A, and so on, okay? Some CI, software CI has been changed. But anyway, so far, 3D Max design version, so far as I know, 2015 is the latest one. And AutoCAD, actually it doesn't matter. Revit, we are using 2016, but that's okay. But you can take a look, architectural aspects newly developed for the new version, the latest version 2017. I found some article to describe what features newly developed and added on Revit, okay? Some architecture related things on Revit architecture. Actually, long ago, 10 years ago, Revit used to be Revit architecture, Revit MEP, Revit structure, and so on, separate version. But nowadays, I thought there is only one single version, Revit, but I'm not sure. Please check by your own interest whether Revit architecture and others separate or not. But anyway, this semester's version is so far 2016 anyway. For your own interest, you can download, you can easily, you know how to acquire the CD keys and download the files, and you know how to activate by student, okay, using your student account. Okay, the software versions evolve, okay, annually, monthly. So I always put emphasis on behind the technologies and some background theories, okay, mechanisms, not the surface user interface, okay, user interface issues. It's subject to be accustomed, okay. You can get used to it in a couple of hours, easily, quickly. But without comprehending, without understanding behind the technologies, mechanisms, what's going on behind, and then entire newer version applications are totally new to you, okay? So please keep in mind my focus as always. And also the topic for today and rest of semesters, that's one type of issue is interoperability, okay? Interoperability in AEC-FM industry for design geometry and or BIM. Okay, we are in AEC-FM industry, okay? But actually, specifically say, some of you and even me are included in interior architecture industry or interior design industry. Whatever it is, interior architecture design is our department. So where is interior design, interior architecture? Okay, possibly we can, the subdomain of architecture was just one of the domains, AEC, architecture, engineering, construction. But I like to bring your attention, we need to put an emphasis on FM, okay, facility management. What is facility management? Facility management, simply say, buildings could be regarded as facility, okay, your asset. So your assets are subject to be managed, okay, under your management. So what if we are saying interior design is one of the subdomain of FM, facility management? In terms of maintenance and management, your design is supposed to be renewed, okay, based upon yearly base, biannual base, okay, new design, refresh design, and reconstruction, reinstalled, okay. So that's why many people think interior design, interior decoration, interior architecture is one part of facility management, okay. For the new building, of course, there is architecture design, interior architecture design, interior decoration. But until the end of lifetime, I mean, until the demolition of that building, no architectural design again, okay, except interior design. In the perspective of facility management, okay, refresh your building, renew your building, reconstruct your building based upon new objective, new goals. So interior design could be one possible subdomain of FM in a specific way. Another one, FMers. FMers means the people involved in facility management. Who are they? Architects, users, designers. Actually, FMers are owners or close to owners. What that means? They are decision makers, okay? Whatever they determined about new design, refreshing design, renewal design, their decision, their determination going to be soon to be realized by designers, contractors, construction managers, and construction companies, and so on. So FM, someone who's in charge of FM are close to owners or just owners, okay? So-called decision makers. So working with FMers means working with someone who's in charge of decisions, okay? Bigger role in decision making. So anyway, it's not the main story in this lecture. Anyway, I like to bring your attention, more attention to facility management, okay? Even if you are working in interior design or decoration domain. Okay, why interoperability? Our goal, objective, anyway, design and human creativity area, it's out of the boundary of computing technology. Using computing technologies, we are authoring design, developing design, visualizing, analyzing, updating design, okay? In computational processing. A little bit overlapped, okay, human creation area. So that's design computing. Human creativity area is totally different area, objective goal, design, and means is computing technology. Overlapped part is artificial intelligence, machine learning, deep learning. In design computing area, we call it design cognition area. So anyway, I'm not talking about this issue. In this computing technology-based design process, what is the issue so far we didn't tackle? That is actually collaboration, okay? Collaboration is very critical issue in our domain because for one building in general, in statistics, around 1,000 people involved for new building project, okay? Possibly sometimes several thousands of people, sometimes some fewer people, of course. But anyway, lots of data exchange, file exchange, and we need to keep updated, okay? Keep updated design, as always, for changing, updating our design and scheduling, construction, material. Lots of issues arise in this process. So, too many stakeholders, okay? Owners, FMers, planners, some administrative officials for law-related things, and some designers, design groups, workers, some construction group people, engineers, engineering group workers, related people, subcontractors, suppliers, someone who's in charge of safety, and some associated issues. Too many people involved in a single building project, okay? So in this process, we didn't look at the collaboration issue in detail, but let's take a look a little bit about it today. I think you already know collaboration is a really big issue, even in small size design studio team, 2 or 3 persons in your team, you realize that collaboration is not always going well, okay? You already experienced collaboration well is not possible. Even by 2 or 3 teammates, it's not well collaborated. You already experienced. So 1,000 people collaboration, 500 people's collaboration, it's almost not possible. But let's take a look, conventional architectural 3D computer graphics and its collaboration. How to share the files, okay? Your design an idea never seen before you mention it, before you draw something, okay? You have to draw, you have to say, represent something because it's only seen by you. That is why digital design presentation or just design presentation required, okay? You have to draw plans, elevations, sections, axonometric, isometric, diagram sketches, animation, and so on, always from your brain, your head. That's why it was repetitive task, very tedious, time-consuming, and sometimes never-ending, okay? From your brain, you're drafting. From your brain, your diagram, your sketch, your animation, your section, your 3D, hand drawing, very recursive and time-consuming. But nowadays we are using computational model. You have learned SketchUp, 3D Max, Rhino, Grasshopper, Rabbit, even building information modeling tools, and so on. Okay, one single integrated model can extract, export digital design presentation material. Plan exported by model, 3D sketch pictures all extracted from models. Even animation, anything can be extracted from the model. So there is one holy source and multi-use, okay? So computational model plus information, so-called database. Model plus database is BIM, okay? That's the definition of BIM defined by AIA. One very salient aspect of BIM is here, okay? Shareable. Without this computational model, how to share this idea, how to share this concept? Your sharing device, sharing media, also your presentation media, okay? So you update, if you update plan, drawing, sketch diagram, your hand drawing, your presentation method and your file sharing method also updated. But if we use central computational model as a shareable device, what we need to update is this one, okay? Sometimes even if we update, our information never been updated. Or sometimes something changed, but my information, my subject doesn't need to be updated, okay? So what this mean by the term shareable? How to share this one? How to share this computational model? Let's take a look at this ArchiCAD example. Okay, there is an ArchiCAD model, ArchiCAD Graphisoft application, Revit-like BIM tool, okay? This one has functionalities to import and export several file formats like this, such as DWG, AutoCAD file, DXF, DWF, some CAD files, SketchUp model, okay? Even Bentley DGN extension file can be importable and exportable by ArchiCAD. But unfortunately, Autodesk Revit file, RVT file cannot be importable or exportable directly. But 3ds, PDF, even text file, DOC, Word file, and Excel file, all importable and exportable, okay? So what are those files? They are mostly design geometry file, okay? Geometry contained by those geometric files. How about those files? PDF, text, XML, including this file as well, okay? Excel file. They contained design data, design information, so-called building information, okay? Non-geometric data, okay? In Word file or Excel file, we can add some drawings, but they are just images, not CAD drawings, not vector files. That is why we are saying non-geometry file. Okay, how about this one? IFC. IFC means Industry Foundation Classes. Actually, IFC file, I introduced you last time before. IFC is one file format in this domain, in BIM domain, as a neutral format to contain everything, okay? Design geometry as well as non-geometry design data, design information. So if you have IFC file, you have almost everything for that building, okay? So there is no functionality to import, export Revit or others. But if you save IFC file in Revit, and if you open IFC file in ArchiCAD, you can keep editing your Revit model, even in ArchiCAD, okay? So simple data exchange or file exchange is give your floor plan to your teammate, your floor plan, your elevation. That was your file exchange. But in this domain, in this BIM area, not that simple, okay? Geometric data and associated information, properties, attributes, and their relationship. Very complicated. They need to be kept consistent, okay? That's another big issue. Anyway, interoperability is something beyond file exchange, file or data exchange. Okay, this was ArchiCAD example, and let's take a look at this one. How to share this computational model. Take a look. Word, Excel, amount of geometric file formats. There are too many file formats, okay? But IFC, IFC XML, IFC zip, they are. Actually, we can say only IFC, okay? IFC is only one single file format to support design geometry and information, including everything, okay? So in terms of interoperability in BIM, that we can say we are using IFC for interoperability. But actually, we are not just talking about BIM. We also need to talk about geometric file exchange and data exchange, information exchange, and so on. How to share the computational model. Let's take a look in terms of this life cycle, okay? Building life cycle from planning, designing, until demolishing the building, okay? At the beginning of the project, the most important thing is visualization, because your design never seen before to others. So you can express by your oral speech, but oral speech is not enough. So you have to draw something. That is why visualization is critical. And in school, in your design studio, we are mostly focusing on this phase, planning and design phase, okay? Of course, we cannot construct in real world, in real scale, one-to-one scale. That is why our focus mostly on visualization. But let's take a look more broad, okay? Visualization, of course, that's really critical, but we need to expand to something geospatial information, which contains GIS data or geospatial data using Google Earth or Google Maps you already use, okay? And also some specified CAD files, CAD models, some type of simulation. I'm not talking about entire level simulation. Some certain type of simulation, such as building circulation, area, or restrictions, and so on. IFC contains almost everything, okay? Even infrastructure, some management things. But anyway, in this planning and design phase, just before construction, our focus mostly on visualization. But for your future job, okay, for your expanded job opportunities, of course, I like to encourage you to take something expanded aspect, something broad aspects of design and construction in terms of building life cycle. So let's quickly look at some demonstration videos, okay? Very brief and short videos, okay? Two are from Autodesk. First one is something about building design suite. Next one is something about Autodesk 360, all about interoperability as well as collaboration, okay, using Autodesk technologies. Actually, there are some commercial, okay, advertisements, but I'm not talking about their advertisements. Let's take a look what's going on in this era. The first one is Autodesk Building Design Suite, okay, just a second.
Autodesk Building Design Suite is a comprehensive software solution that combines BIM and CAD tools to help you take advantage of Autodesk's portfolio of software for architecture. Design, visualize, simulate, document, and build better buildings with a set of tools that supports an end-to-end project workflow. Design better buildings. Built for building information modeling, Autodesk Revit helps you model design concepts and more accurately maintain your vision through documentation and construction. Any design change you make is updated throughout your project, keeping design and documentation coordinated and more reliable. Communicate your ideas more clearly and effectively to help win business and gain stakeholder approval. Autodesk Showcase provides an easy-to-use, real-time 3D presentation and rendering tool that helps transform designs into compelling imagery, movies, and live presentations. When you're ready to produce jaw-dropping visuals of your designs, Autodesk 3ds Max Design provides advanced modeling, rendering, and animation tools to help architects create cinematic quality visuals. Use integrated simulation tools to help inform design decisions earlier in the process. Energy analysis tools in Autodesk Revit provide architects with powerful, cloud-based analysis capabilities that enable you to quickly gain insight into the energy consumption and building life cycle costs of conceptual and detailed designs, helping you design more sustainable buildings. Create more consistent, higher quality construction documentation with powerful tools that provide native DWG support and automation tools that minimize repetitive tasks and speed time to completion. Improve control over project outcomes by sharing valuable design insight with all project stakeholders. Autodesk Navisworks enables the integration of multiple 3D models and data formats into a single model that architects, engineers, and contractors can analyze and review for better coordination, conflict resolution, and planning long before construction begins. The Autodesk Building Design Suite is a comprehensive software solution that combines BIM and CAD tools to help you design, visualize, simulate, document, and build better buildings. To explore which capabilities best fit your specific industry workflow needs, download a free trial and experience the
Okay, this was the commercial video from Autodesk to show their application capabilities. Even in 2013 versions, anyway, their collection of applications named Building Design Suite has lots of tools, including Revit, as this video showed you, and 3D Max we are using for design visualization. And also there is another one, Navisworks, for construction management, okay, scheduling, construction process management, importing amount of different file formats, heterogeneous file formats, DWG CAD formats, 3ds file, Max file, IFC file, even totally different file formats can be loaded into same environment to make sure that for the real construction. Okay, next video shows you another one, 360, okay? I think some of you already, I showed you those series of videos before, just for your information. But anyway, at this time, let's take a look in terms of collaboration, interoperability, and the use of advanced technologies such as cloud-based servers, cloud-based technologies. You already experienced cloud-based rendering using homestyler.com website, or cloud render defined in Revit, or the last week's some example case that I show you, Backburner, 3D Max, some shared render features, and so on. Okay, anyway, let's take a look at the video. Okay, the next generation of BIM, actually too much idealistic. In real world, we encountered amount of technical problems, issues. But anyway, one thing that is clear is this is anyway the way to go, okay? In the video, the conventional collaboration was based upon email, FTP, file exchange, file transferring, uploading, but new collaboration supposed to be some cloud-based collaboration environment. There is centralized platform, centralized environment, and someone who's in charge of editing some features, they update, change, view, share using that cloud-based centralized model, centralized file. That is so-called up-to-date model, keep up-to-date models in one single project collaboration between different stakeholders, okay? So anyway, cloud computing, as this video showed you, there are amount of computing powers, resources available. So let's take advantages of such available computing powers in order to get some appropriate result, what we want. Okay, next video, actually not from Autodesk. This one from Graphisoft, okay? Graphisoft is ArchiCAD company. Actually, I believe I introduced you this one also before, but according to this video, let's take a look at what is real interoperability, real interoperable collaboration, okay?
A building project has many participants, including architects, engineers, consultants, constructors, and so on. They all have different roles, goals, agendas, and priorities. And firms usually run a number of projects in parallel. Combine that with the differences between building standards and conventions in different regions that require different solutions, and you'll understand why a single platform strategy is not the solution to the AEC collaboration. So if file compatibility is of little worth solving collaboration problems, let's see what the solution might be. Joe is an architect, Martha is an engineer, and Don is a constructor. They're working on the same building project and need to coordinate their work. Let's say Joe is designing a decent-sized building and needs to coordinate with Martha, the structural engineer. Joe sends his BIM model to Martha. And what does Martha get? The architectural BIM model that's full of architectural details. Such details are just noise for a structural engineer who needs only the load-bearing structures. So, she either cleans up Joe's model or starts the whole thing over from scratch. What we need here is workflow compatibility to ensure that the other party only gets elements relevant to her part of the job. Now that we've managed to get the appropriate part of Joe's model over to Martha, is she able to start her part yet? More often than not, the architectural logic of the BIM model doesn't 100% match the structural logic. For instance, columns in the architectural model may be modeled as walls, but the engineer really needs columns there for a structural analysis. What we need here is workflow compatibility to ensure that element interpretation is correct, regardless of the differences between the parties. Now we've solved these issues. Are Joe and Martha finally able to get to work with their respective models now? Sure, but as they progress, they continuously have to keep their work in sync. What we need here again is workflow compatibility to ensure that communication is bidirectional and that changes are handled in an intelligent way. You may have already noticed, but it becomes even more obvious once Don the contractor gets into the picture, that Joe and Martha were actually working on separate BIM models and only used the other party's model as a reference. The reason is that workflow compatibility requires that the real-world setup be mirrored, where parties carry full responsibility for their part of the project. Hence, they also require full ownership of their own BIM data. As you witnessed in the previous 4 workflow issues, it's not file compatibility, but rather workflow compatibility that can make or break open collaboration between the various stakeholders of the AEC industry. With open collaboration, all participants of the AEC workflow enjoy unique benefits. Project members can choose to work with best-of-breed solutions in their respective field and location. Project members can decide about their software upgrades independently from their peers in different projects. Project coordination errors are greatly reduced due to workflow level compatibility in contrast to file compatibility. Accessibility of BIM data is provided throughout the entire life cycle of buildings, including construction and operation. To enjoy all these benefits, you're welcome to join the Open BIM community today.
Okay, Open BIM. In other words, Open BIM means IFC, okay, Industry Foundation classes, which means to support entire building information model, including geometry and associated data, non-geometric data for the building, okay? So that's why IFC is the one single neutral file format in BIM domain, okay? Of course, Revit file, ArchiCAD file, Bentley file, digital project, CATIA, Dassault system, lots of BIM tools and their own commercial files, but there is only one single file format to contain everything, to be shareable, okay, in this domain. Okay, let's quickly finish the rest of the slides and then move to the lab exercise. Let's think about we are designing a wall surface, okay? 2 approaches. First one is by geometric modeling and rendering tools. Design visualization tools we have learned and used for general design and design visualization tools like 3D Max, SketchUp. And another one is parametric modeling approach. Let's quickly take a look. Okay, Maison Escalier, let's take a look at this real building case. In this building facade, as you see, inspired by trees, foliages, there is a specific pattern, okay? It's one of the sunshade system and very unique feature of building surface, okay? Facade system for in terms of its design. Let's take a look interior features of this scene. Because of the pattern geometry, penetrating sun rays cast some this kind of shadows, okay, and very bright and very unique visual effect like this. And also parametric modeling approach, we have learned some type of parametric modeling approach based surface making, okay, wall making, including Dali Museum case. Rectangle shape, flat part generation. Okay, how to easily draw them, okay? How to model them. First one is, of course, even if it's parametric modeling tool or geometric tool, whatever it is, in the bottom level, basement level, anyway, anyhow, we have to handle geometry. So fundamental way is draw the pattern, okay? Draw by hand this pattern, geometry. But of course, it's really time consuming. So we need to use some parameters. At this time, not parametric modeling, but something parameters defined in geometry. In this case, generate topology, okay? Graphite modeling tools in 3D Max, there are some random pattern generation algorithm predefined by developers. What we need to do is creating meshes, polygons, and apply this kind of auto-generation algorithm, predefined algorithm, okay? This is geometry approach, but something somewhat parameterized. So thanks to this random algorithm, we can get this kind of pattern geometry, okay? The pattern. Random pattern, tether, or some other procedural ways. Take a look. This kind of pattern can be easily created by one single pattern making algorithm in random, okay? So this one can be 3D simply using shell, okay, inset and shell, and then take a look. Mental ray sans option, shadow softness 0 or softness 4, and you can see the difference, okay? And this is Photoshop retouch. So this is one of your lab exercise for today, okay? Lab exercise number 4. And parametric modeling tool approach, of course, here it is. For this one, we have project surface design, okay? It's not related to the part design, okay? Part can be rectangle shape, triangular shape, hexagon shape, whatever it is, okay? We can apply some different patterns, or even it could be not a glazing, okay? It could be anodizing aluminum, totally freeform. Anyway, as based upon our review, as we reviewed for the design and Dali Museum, some other cases, part design and part definition, and they can be applied for this surface project without any problem. But my point here is, this is modeling tool, and we have learned Revit, but the geometry of this one can be imported to 3D Max, okay? Okay, some series of, okay, whole serial-like surface, and some application demonstration and some sequence slide. Let me skip those introduction because we reviewed before lots of times. So today, okay, I like to bring your attention to this mental ray environment we used for 3D Max visualization. Take a look, this triangular shape geometry. This one edited in Revit, but by using DWG or FBX, easily importable to 3D Max environment. And at this time, simply assigned gold-colored metal surface-looking object material like this. But how about this? Take a look, this one. Gray-colored matte surface. But the difference between this one and that one is, of course, its surface geometry changed, and the parameters, I mean, the depth, thickness parameter totally changed. This one is looking frame structure, and this one, take a look, has much thicker, very deep structure for its triangular shaped geometry like this. Unfortunately, the depths and the part geometry couldn't be controlled in this 3D Max, but if you have family file, Revit file, and the Revit model, you can control the geometry, part geometry, and the surface geometry. But anyway, the project surface scale, location, angle, some geometric aspects, of course, free to edit in 3D Max. That's my point. They are lab exercise number 5 and 6, okay? So designing a wall surface using both ways, we can get some organic shape or container-like structure easily, but they are totally different approach we have reviewed, okay? Geometry-based approach, parametric modeling-based approach, okay? Geometry-centered and object-oriented using part and assembly. So you know the difference, pros and cons. To sum up, easily you can sum up, okay? If you know only SketchUp or 3D Max or Rhino, whatever it is, you can design only what SketchUp or Rhino or 3D Max supports, okay? Knowing pros and cons, that is important, that is critical. So, as always, to take advantages of various kinds of applications for your design developments. That's the goal, okay, for the design computing related course for today. Okay, let's finish today's lecture. We're gonna move to the lab exercise quickly. After the break, 10-minute break, okay?